allow me to introduce myself. I'm Ben Root. I am one of the Matplotlib core developers, and this is my reimagining of how to teach Matplotlib. A few years ago, I actually sat through one of the other developers' Matplotlib tutorial, and I was just shaking my head. I was just like, "You're making it too complicated." Yeah, this is how you. Yeah, I wanted to do just a complete redo of just how to do it, and it was a rousing success last year, and so I submitted it to be presented again this year, and with some revisions. And I hope you guys really learn something from this, and just and also help spread that knowledge around to your coworkers, colleagues, and such. The tutorial itself is BSD license, so you're free to take it, modify it, and do with it whatever you will. And I would certainly also appreciate any patches back if you find that there's certain sections that could be better or there's more stuff could be added. So, everybody good to start? All right, let's get started. I have broken up my tutorial technically in 4 sections. You'll see 5. There's a part 0. The original version of this tutorial was given to my coworkers at the company I work for, who really needed a from the beginning introduction. So I had a part 0 for intro to NumPy. We're not going to do that section. We're going to go right into the PyPlot one. But if some of you guys are just interested in just seeing a really quick primer in NumPy on your own time, go ahead and take a look through that. Although if you're running Python 3, I've just been told that I made a stupid mistake in there, so I'll have to fix that later. So we'll go to Anatomy of Matplotlib, Part 1, PyPlot. Just click on that section and we'll get started. And there's a little bit, there's IPython magic there at the top, %sign Matplotlib inline. We're going to be in inline mode for most of this presentation. There'll be like one or two sections where we'll go out of inline mode. So Shift-Enter on any of those code blocks will execute it. So once we execute that, we'll be good to go for a lot of the code in this section. Okay. Matplotlib is a library for producing publication quality figures. We're here at SciPy, so presumably you're all scientists of one form or another, and one of the most important aspects of being a scientist is publishing. And one of the most important aspects of publishing is figures, and being able to communicate your results and your data in a way that makes sense to other people. But that's not the primary, that's not even like the only use of Matplotlib. Matplotlib is used for a variety of other uses, but we're going to focus on this core use of publication quality figures for your use in communicating your research and your results. The originator of Matplotlib, he was a biomedical researcher, and he was doing. He needed an interactive way to deal with brain scans and such, and now it turned into this thing that's used across the world for plotting anything really, and it's interesting to see its growth over the past 10 years. Online documentation is a very, very good idea to become familiar with it. Matplotlib.org is broken up into several sections. We have an examples section. We have a gallery. And then we have API. We also have an FAQ. things like that. What is the gallery? So oftentimes, you'll have a situation where you kind of know what plot you want, but you're not quite sure how to make it. And you go, I want a plot that has this and that, but I need to have the x-axis done a special way, and I need to have a legend that's not on the axis but off of everything. And good luck trying to enter that into Google or Bing or whatever. You're not going to get an answer. The gallery is what known as the poor man's search engine optimization. You can go to the gallery, and it is broken down into a variety of sections, but you actually see a whole bunch of example plots done in a variety of different ways, using a variety of different tricks that Matplotlib allows you to do, and you can pick out, you can recognize, hey, yeah, I need my legend to look a little like that. You click on that figure, and you can see the code that produced it, and you can pick and choose different examples and go, yeah, I need a little bit of that. Oh, yeah, I need to highlight bits of my line plots this way. How do I do that? And you can learn these individual sections. And like a chef, you'll be able to start mixing and matching and producing your works all on your own. As an additional resource, we have the Matplotlib users mailing list. This is an excellent, in my humble opinion, excellent resource to go to and get help answers to questions that you might have. You can describe things. Oftentimes, like a question comes up, they go, I'm trying to get the plot to look like this, and they'll link to something else on the web. But this is what I have so far. And usually somebody will be able to help bridge that last little bit of help to get your plot working the way you want it to be. So it's an excellent place to get answers to questions like that. Another place that has been gaining popularity is the Stack Overflow. I actually didn't even know until last year that it was actually becoming popular, that more questions were being asked on Stack Overflow than on the mailing list, but both places are excellent places to go to for answers to your questions. Where are we located? We're on GitHub. We also have our bug reports and feature requests taken care of there through GitHub. So again, if you ever encounter anything where you're going, this is just not working, you can issue a bug report through GitHub, and we can usually work it out and figure out what's going on. You're going to hear about backends. Matplotlib has multiple backends. The backends allow Matplotlib, or MPL for short, to be able to use on a variety of platforms. So it works on Windows, Macs, Linux. We even have some people who managed to make it build on Solaris. And a variety of different toolkits. We support WEX, TK, GTK, Cocoa, Qt, and even the Windows. I think we support the Windows one. I can't remember. We support a whole bunch of them. And so oftentimes, one of the things that you're going to be asked when you submit a bug report or have a question that something's just not working right, we're going to ask you for the version of Matplotlib that you're running and which backend you're using. If you don't know which backend you're using, you can run the following 3 lines of code. No, if you're running Python 3, these print statements won't work. I'm sorry, I was stupid. And so in this case, you'll see that I'm running the development version of 1.4, and that my backend right now is the PyLab the notebook backend that's in IPython. So knowing these two pieces of information will be very, very valuable for any bug report or questions that you submit. Because usually, while most backends, it doesn't matter which one you're using, there are some rare situations where a bug is very specific to a backend, and so that usually helps us figure out what's going on. So, you're probably getting tired of me yammering and you actually want to learn something. So, I shall start with the two most important import statements you will ever need to worry about. Import numpy as MP, import matplotlib.pyplot as PLT. That is the standard convention used for importing Matplotlib. So what is Piplot? The Piplot module is where everything in Matplotlib comes together. Matplotlib is made up of many, 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 many parts, and Piplot brings everything together in one place, and that is usually the interface that you'll be dealing with. There's also another interface called Pylab. It is not evil. It is not wrong. However, I'm not going to be talking about Pylab today. At a Birds of a Feather session later this week, I will actually be giving a devil's advocate defense of Pylab. So if you're interested in seeing such a defense, please come to the BOF, and it'll be an interesting show. Please bring your rotten cabbage and such to throw at me for ever suggesting such a thing. So, in Piplot, there's a whole bunch of functions in Piplot module. It's dizzying. It's so difficult to really understand exactly what you can and can't do. So I broke it down to 3 general categories. There's the prep of the plot, there is the making of the plot itself, and then any modifications to the plot that you have produced. It's not clean exactly how I broke it up. For example, I have a savefig under plotting prep, when savefig is the last thing you do. But you can see we have functions for producing axes, for clearing an axis, for clearing the figure, for setting color limits, for deleting axes, setting your margins, setting your hold state, interactive off, interactive on. You can query various things. There's the savefig command there. You can set a variety of, you can set up all your subplots, setting up your tick parameters, a whole bunch, setting your labels. A whole bunch of things that are very, very useful stuff for not the actual plot itself, but the things that decorate your plot, getting them ready and getting the appearance looking the way you want it to be. Then there are the actual plotting functions, such as bar, we have barbs, we have contour F, contour, error bar, fill between, hex bin. Hex bin I really, really like. It's two-dimensional histogram. It's a heat map in a sense, but it will do the histogramming for you in 2 dimensions. Then hist2d is another one. Just hex bin will do hexagonal formation, while hex bin is rectangular. So IMShow, plot, pi for pi plots. You do scatter, quivers, stem plots, stack plots, and then there's the try family of functions that use triangulations. Again, you want to see more about them, they're all available on the Matplotlib website to learn about. And there's examples for nearly all of them. Then we have the plot modifiers. This is further decoration of your plots that specifically annotates and changes how your plot appears. So annotate to help label sections of your plot. We have AXH ax h line, ax h span, ax v line, ax v span. What those are basically if you ever needed a line that no matter how you zoom or pan around, that line will always span the entire length of your axes. And then so that's the line, and then the span is like you have multiple axes, and you want that line to go all the way through, show up in each of the axes the same exact way in the same location, so you can do that. You can add boxes, you can label your contours, add a color bar, you can set your minor ticks, you can add the legend / key for your quiver plots, add a title, a whole bunch of different things, and adding your labels to your axes. So that's just the Piplot module. And that's not even every single function that's there. I actually left several out. So, and then in some newer versions, Matplotlib, there's newer functions that are available that I haven't added to this list yet. So it's a pretty extensive module, and this is usually your starting point. So now we start getting into the anatomy of Matplotlib. How exactly is Matplotlib structured for its use? And to start with, you have your figure. The figure is quite literally your canvas. So we're going to create a figure. And you see that IPython reported that I have a figure object, but nothing happened. IPython didn't show anything or anything like that. That is because, by default, in Matplotlib, interactive mode is off. Even though you're in IPython, interactive mode is off. We will not actually show your figure until you tell us to show it. If your interactive mode is on, it will pop up immediately. Anybody here MATLAB users? MATLAB, what you're used to is basically the equivalent of interactive mode being on. As soon as you start plotting, that figure will show up in MATLAB. In Matplotlib, it is the opposite. It will wait until you're done. This actually has a lot of benefits. For one, if you're scripting your code to generate your figures, and you're running it, let's say, on a server, well, who's going to be there to, you're going to call over the administrator in your data center to go to the monitor and go, I need you to close this figure. Yeah, not going to happen. So interactive mode is off, and it's perfect for that sort of situation. The other advantage of it is that we don't have to waste computational cycles on refreshing that graph every single time you make an update to your figure. Anybody here ever done p-color in MATLAB? P-color will immediately plot something, and if you're doing a heavy plot, you're doing p-color first, then you're setting your color map, then you're setting your x label, and then your y label. And each of those subsequent commands, it has to redraw that p-color. I hate that. So you'll hear me razzing on MATLAB a lot. It is the reason why I found Matplotlib. So thank you, MathWorks. So there are two particular properties that one could set for a figure. That's their there's a few others, but there's two main ones. There's the figure size, and there is the dots per inch (DPI) resolution of the figure. Yes, I know it's not metric. There are a few Europeans that like to razz on us for using inches. I'm sorry. So we're going to show an example where we're going to create a figure, and we're going to set its figure size to be 10 inches wide and 4 inches tall. So the first element of the tuple is the width. The second element is going to be the height. And then because this is IPython, you have to set the axes object for the figure, else it won't show. But in regular Matplotlib coding, you don't have to do this in order to make things show. But we're going to execute that block, and we now have a figure that is 10 inches wide, 4 inches tall in its entirety. It's not the part that is framed. It is from the edge of the white to the edge of the white. It is that size. Oftentimes you'll run into a situation where you don't really know what size you want, but you know what the aspect ratio is. So there's a really neat function in Piplot called big aspect, where you can say that you want something to be twice as tall as it is wide, and it'll produce a set of inches height and width based upon the default value, and so really useful. So I say that it's going to be 2 times as tall as it is wide, and there you go. Nice and easy. We're going to, if you got my tutorial, there's a file in that directory. It's an SVG file.
I have kind of basic interface question with the use of the notebook in the inline mode, because what you do with the show, I just type take and I get it. So
Yeah.
is there something preferred way that preferred by using show here?
So the question is, why the heck am I using show when you don't have to? I am using show here for the purposes of this tutorial because when you're not in IPython, you need to use show. When you're in IPython, IPython tries to be really, really helpful. Yeah. When you're in IPython and you don't do show, but you finish executing that code block, it will do show for you automatically. But for the purposes of teaching Matplotlib, I need to make sure everyone understands that usually when you're coding up things in Matplotlib outside of your IPython session, you will need to use show. So that's the purpose of show, is that it will trigger the plot creation when you say so. It's just IPython's trying to be very helpful for you by doing it for you if you didn't do it. That make sense?
If I were to take a ruler to the screen, I don't think I would find it 10 inches wide.
You don't
So, yeah. But if I were to take a ruler to the screen, I would not find it 10 inches wide, and the aspect ratio is not 2.0.
So the issue that doesn't think that the aspect ratio actually is exactly 2.0. I would have to take a look at the properties of the figure. There may be some sort of estimation.
It's certainly not 10 inches wide.
Well, no, it's being scaled. It's being scaled when it's displayed in the browser. It's being scaled but the bitmap or the PNG file itself records that it is that particular width. And so if you were to actually print it out unscaled, it will come out that way. Now, as for the aspect ratio itself, there might be a bit of an estimation bit in the code to try to give it, in such a way that there's an even or a particular number of pixels, that there's no half pixels or things like that. I would have to take another look at that section of code, but this gets you roughly where you want to be. So. Mm-hmm. The save big command. The save big command, you'll actually then specify that you will, the name of the file that you want. And so you'll say plot.savebig and then foobar.png, and that will save the figure. Now, there's a very excellent question in one other aspect that I forgot to mention is that when you do the show, when you do plot.show and the figure window pops up, your execution will stop until you close that window. So if you were to put a savefig command after your show, you have destroyed your figure when you close that window in order to move on to the savefig command. The figure no longer exists, and your savefig will fail. So you need to always put your savefig before your show if you want to be doing save. Now, in interactive mode, when you get the figure up, you can there'll be a toolbar, and you can actually choose to save the file directly there if you want. So there's two ways to save. There's either programmatically through your code, or you can save from the figure window directly. So that's available. But never put your savefig after your show, because it will not save the figure, because the figure will be gone by then. Does that make sense, people? It makes sense once you start programming and getting used to Matplotlib itself and understanding a little idiosyncrasies with that, because we can't be keeping the figure around after you close that window, because it takes up so much memory, because we're holding all that data in memory. We have to release it at some point. So when you close the figure window, that's as good a time as any. Now, you don't have to use show. You can make scripts that never pops up an interactive window, but you can still save the figure. And so that, I do that all the time. My scripts, usually I'll have a command line option for no show or show, depending on what I want the default to be. And it will just go and make the figure, and it will save it. And whether or not I tell it to show or not, it will do the show if I tell it to do so. So many of my scripts actually will never pop up a plot window, because I don't want it to. I just want it to generate plots for me all the time. So it's useful that way to understand that there's the interactive part and there's the non-interactive part, that all very, very useful. So we're going to go to this SVG file, plotdemo.svg is in that directory. We're going to open up tab, and what you could do is, as you mouse over different parts of the plot, in the upper left-hand corner, you'll see names for some of the different parts. So I'm over the x-axis spine bottom. Then there's the axis title, the soup title. We have the Y label. We have the Y tick label. You know, we have all these different parts of the figure that is help named. And so this is useful to help know what the different parts of your plot are called, because oftentimes Matplotlib mailing list questions come across where somebody's describing something and they're using all the wrong terminology, and it takes a long time to figure out what their problem is, because they're calling something, you know, something that isn't what they're thinking it is. So this SVG file here is a useful reference to find out what it is that you are talking about if you don't know what the names are. It also helps in knowing what functions to look up. If you need to look it up, you can look it up by name that way. So that's just a nice little useful thing. Oh, I want. Ah, good. All right. Sorry, I closed that tab when I shouldn't have. Where did I? Okay. All right. So now that we know what the names of the different parts of our figures are, and we know what the figure is for and how to create a figure, show a figure, and save a figure. So if I wanted to save this particular figure somewhere, I would do, you could do plot.savefig if savefig foobar.png, or you can directly do fig.savefig. So you could say that this is the figure that I want you to save. If you do plot.savefig, it's going to assume that it is the current figure. There's this concept of, if those of you coming from MATLAB background, there's the GCF and the GCA, the current axes, the current figure. Piplot has similar concepts as well. So whatever was the last figure that you were modifying is going to be the current figure. So, but I like being explicit. I'll say fig.savefig. So note I did the savefig before the show. So now we'll see. Open file, you'll see I have foobar.png now in that directory. That's how I saved that figure. So now we move on to the next component of the Matplotlib anatomy. So we have the figure. Now what you put inside the figure is called the axes, also known as a subplot. Now many of the functions that you saw in that listing, yes?
Sorry. When you save that figure, how do you call up where that figure is saved to?
It's a file name. So when I just said foobar.png, it just assumed the current working directory. So it's just like saving, a text file or loading up some other data file or something like that. It's the same exact semantics. It doesn't try to be cute and put it in some special directory or something like that. Whatever directory location you say is going to be that. Now the format of the image, we do try to get cute on that. If you don't specify the format of the image file that you're saving, we will try to figure it out based on the extension. So I said foobar.png. So it saw PNG, it's going to assume that you want a PNG file. But I could have said JPEG, I could have said BMP, or PDF, or SVG, and it will try to automatically figure it out. You can also explicitly override that as another argument to savefig, but most of the time, you want your extension to be what reflecting what format the image is anyway. So, okay. So moving on. So with the axes object that we're going to put in the figure, so many of the functions that you saw for the Piplot listing are also there for the axes object. So we saw for Piplot X label, Y label. Well, the axes object has set X label, set Y label. So many of the, and Piplot works by going to the current axes and calling their particular functions, those particular methods for the current axes that way. So Piplot is a layer on top of the axes object. So we're going to show a very, very simple example where we're going to create a single axis through the command called add subplot 111. Again, those of you from the MATLAB background, this looks very, very familiar. It means that I want that I'm assuming that there's going to be one row, one column, and that I want the first axes. It's a syntax that's been in MATLAB for years, and we adopted that. We have other ways of creating subplots as well, but this is the one that helps a lot of people transition from MATLAB to Matplotlib. So we create our figure. For that figure, we say that we want to add a subplot, and that then we're going to actually do a very simple plot. You know, I have my x values and my y values, and then I'm going to set my limits. So x.set xlim, and then I'm going to show it. Nice and simple. The limit went from 0.5 to 4.5, just like I told it to. But notice I didn't tell what the y limits were going to be. It automatically figured it because I did not tell it what the y limits were. This is something that Matplotlib does. Our philosophy is that you can control every single component of your plot. There's nothing that we hide from you. However, we have a powerful default system that will usually pick the right answer for you if you don't tell us that you want to control that. So that is often its power, is that it's so easy to get started in Matplotlib, but then you could drill all the way down to the bottom layers and control any aspect you want. Yes? Which axis to what? So you want to know that for a given axis object, which figure it was for?
Other way, right? Or vice versa, either way.
Yeah. Every single figure object knows what its children are, and every single children knows what its parents are. So there's a hierarchy. And so an axis object can only belong to a single figure. You can have many axis objects in a figure, but you cannot have multiple figures have the same axis object. This is actually something that a feature that some people wanted, and we had to tell them no. Because it goes back to the whole thing I was talking about with Piplot.show. When you show that figure and then you close it, we destroy everything in that figure. So if you had an axis object that was in multiple figures, it makes no sense because now the other figures have its axis object destroyed as well when you close that one figure. So it makes sense that there's a hierarchy from figure to axes to artist objects that I'll talk about later. Mm-hmm. Sorry, what?
Could you explain the 1-1-1 again?
Okay, so I'll explain it a little bit. I do not encourage its use. Okay, so I could have just as easily have written the following. The question is, I'm going to explain this 1-1-1 and add subplots. I could have done this. This is the correct way, quote unquote. I still don't encourage the use of add subplots in general, but you could say that I want one row so I have a figure, and I know what its layout is going to be. Let's say I want the layout to be 2 rows and 1 column. So that means that there's going to be 2 axes objects, but I'm going to work on n axes object at a time. So I do add subplot, note the singular. That the layout is going to be 1 row, 1 column, and then I want the first one. So 1, 1, 1. But if I had 1, 2, 1, I want the first one of 2, then I'll do my plotting there, and then I'll move on to the next one. I'll say 1, 2, 2. I want the second one. And let's say I wanted a 2 by 2 grid. I'll say 2, 2, 1 for the first one, 2, 2, 2 for the second one, 2, 2, 3 for the third one, 2, 2, 2, 4 for the last one. So, but again, it is a convention I do not encourage, but it is a MATLAB convention. Now, the shorthand of that is to specify a single number as 3 digits. So a 3-digit single number. So 111, we break that up as 111. You could say 211, and that's 211. So it's a shorthand notation.
I noticed that in this case it wasn't necessary to do GCA.
Sorry, the what?
I noticed in this example you didn't have to do fig.gca.
Right, because I did fig.add subplot. GCA, I did because I needed to explicitly tell the figure to add an axis in order to show. Even if I took out that fig.gca and I had that pyplot.show, nothing in IPython nothing would have happened.
Actually, I took it out and there wasn't anything in the SVG file either.
In the what?
I took it out and there wasn't anything in the SVG file. GCA was needed for the SVG file to be submitted.
Well, the SVG file had nothing to do with the fig show.
You're right, but as far as save fig, I found it necessary to put the GCA in there so that the figure could take the axes.
Right, it's necessary for IPython. I guess I'm a little confused by your question. What?
If I say fig equals plot figure and then fig.save fig,
Are you talking about for this code block right here? I have fig.add subplot.
I'll talk about it later.
Okay. So I talk about a little bit with the X limits, the interface between Piplot and the axes object, that when you call plt.xlim, Piplot itself will then call ax.setXlim for you on the current axes. So one is explicit, the other one is implicit, but it's just a thin wrapper around the axes object interface. So this code here, this 5 lines of code up here, is completely equivalent to these 3 lines of code here. Produce the identical figure. So, and I would say that these 3 lines of code is a whole lot clearer to understand and to read and such. So why is it that I'm showing you guys this code example first? Because of PEP 20, the Zen of Python. Anybody here ever heard of that? It's a really neat thing. It's 20 rules for writing good Python, of which only 19 were written down. It's a mining Python thing. And one of the rules is explicit is better than implicit. And so, but however, you don't want to be more verbose than you need to be. So this supports the Zen of Python because when you need to be explicit, which is most of the time, you can do it. And it's encouraged because you're saying that you want this axes object to be modified this way. And that is the one that's connected to that figure. And so if you're writing a lot of library code or other things, it helps to be explicit because you may not know how your users of your library code is interacting with their figures. So they may be doing things that changes whatever the current axes are or whatever in ways that you don't expect it to be, in ways that you may not expect. Whereas if you're sitting at an IPython session or just simply a regular interactive REPL session in Python, these 3 lines of code is a heck and a half a lot easier for you to type. And maybe it's just for some one-off script that you don't want to be having to spend all your time being very explicit. We support both ways of plotting. And so you can either keep it nice and simple and basic or scale it up to a more complicated graph by being very explicit and you know what you're modifying every single time. So now we'll move on to the limits. So you notice that in my example before, I was modifying the x limits, but not the y limits. The y limits were being set automatically. That's the auto scaling. And the basic idea with auto scaling is that given data that you have given the axes object, if the auto scaling feature is on, we will make sure that the limits of your plot will encompass the entire set of data. This may or may not be desirable. For example, let's say you're plotting a whole bunch of values and that are all around 10, but then you have one value that is 1 million, and then it goes back down to a whole bunch of tens. That one outlier, well, by default, we're going to set the limits in such a way that you will see all of it. But that one just simply looks like a line and then just pops up like that. So you, again, have full power to set the limits however you wish. So I'm going to show you we're going to show an example of the difference between auto-scaling and not. And then also, for certain types of plots, we auto-scale a little bit differently than others. In this example, I'm also going to show you the preferred way of creating your subplots. And that is through plot.subplots. Note the plural. So the other one was add subplot, the singular. This is subplots, the plural. You can create multiple axes object all at once, rather than saying, I want axes 1, I want axes 2, you set them all, you get a list of them or a tuple of them, organized however you want, and away you go. So in this case, I'm going to create 2 subplots. I'm going to call them ax1, ax2, and then I'm going to plot on ax1, so ax1.plot. I'm going to plot that one, and then I'm going to do ax2.scatter. And I'm going to plot a different set of data there, and then I'm going to show it. So, actually, I'm sorry, not different set. It's going to be identical set of data, but note that the limits are different. So for the line plot, the x limit went from -10 to 15. It encompassed the data entirely, and that the y limits was -4 to +4. Meanwhile, on the scatter plot, we do a margin. We will pad it by, I think, 5%, something like that, of the range of the data. And in that case, then the x limit ended up becoming -15 to +20, as opposed to -10 to +15. We added margins. And that then the x limit went from a minimum of -5 to +4. So the limits ended up being slightly different based on what kind of plot you were doing. These are data margins. Another trick that you can do with the limits is you don't have to specify both ends of the limits. You can specify only one part of the limit, and then let the auto-scaling figure out the other half of your limit. So in this example, and note that I'm going to be setting these limits after I do the plotting, because auto-scaling doesn't make sense before you plot because you hadn't plotted any data, right? So we're going to do, this is identical code, except now I'm going to set the y limit to have a bottom at -10, but I'm only specifying the bottom. And the x limit to have the right value be at 25. Again, I'm only specifying half of the limits of each of the axes. And we see that it automatically figured out that the top needs to be at +4, and that the leftmost value needs to be at their respective -10 or -15. But the right value for both of them, well, for ax2, I set the x-lim to be at the right at 25. And then the bottom for the ax1 was to -10. So I can anchor my plots any way I want. So you don't have to specify both. And then this is an example of how not to be setting your limits, where in which same exact code, but I set my limits before plotting. By doing that, you turn off auto-scaling. Once you start setting your limits on certain things, auto-scaling gets turned off because it assumes that you already knew what the heck you wanted. So here now, I've lost, parts of my plot that I wanted. So set your limits after you finish plotting. So now we're going to move on to our first example. I want you guys to make a plot that will start at 1,000 at the bottom and goes to 500 at the top. And I have a little hint here, set ylim. And to get you started, you'll see this magic load exercises 1.1, whatever. You can shift enter on that, and that will load the exercise for you that gives you a start. You can't execute this code right now because it's missing stuff. Well, you probably could actually run it. But what I want you guys to do is to figure out what goes in right here for set ylim so that your plot will start at 1,000 at the bottom and end at 500 on the top. Give you guys a few minutes to do that. In the meantime, if anybody have any questions, concerns, thoughts? And that's how you do it. When the tutorial is done, I will upload all the solutions. I don't have them uploaded to GitHub yet because I didn't want you guys cheating. So it's quite simple. Put 1,000 first, and then 500. It's that simple. And you'll see, you will execute this code, and you see that the y limit indeed at the bottom is 1,000, and at the top is 500. Why the heck would anybody want this? Do you have any meteorologists here? Atmospheric pressure at the surface near 1,000, but further up, it decreases with height. You know how many meteorologists use Matplotlib? By the way, any meteorologists here, the upcoming version of 1.4 will support skewed plots. We can do skew T's. Yes?
Looks like in the set y limit function, you specify a lot of why is it that this way? If I'm setting it to the top one,
Why set?
I put 1,000 and 500 top one.
1,000 and then 500 as a tuple?
Yeah, I thought that was it doesn't matter.
Yeah. So the question is that he did. The person asking the question did the following. He supplied it as a tuple directly as so, right? You just put parentheses, right? The set ylim, set xlim functions support multiple ways of specifying. I just showed the most simple way of specifying it, but you can pass in a tuple, or you can pass in keyword arguments. Yes? So, exactly. So when you're passing it in as positional arguments or as a tuple, the order matters. If you pass it in as keyword arguments, the keyword arguments, I would say bottom equals 1,000, top equals 500. Or I could do top equals 500, bottom equals 1,000. But when it's positional or it's a tuple, we assume that the that the order matters. All right. Now we'll move on to labels and legends. So just about anything in Matplotlib can be labeled in one way or another. And when you label a plot, as I will do in this example here, for example, I'll say that this first plot here is going to have a label of Philadelphia, and that this second plot command is going to have a label of Boston. And I'm going to say that this is temperatures in degrees Celsius over time, and I set a title of A Tale of Two Cities. And that then I'm going to call ax.legend. And so what happened is that I labeled these two plots. Well, legend, when I call legend just as is, it's going to go, well, what labels were assigned? I'm going to put them in the legend for you automatically. Again, very powerful default system is that when you don't say exactly what you want, we will infer what you want as best we can. And so we have two line plots here, but and then you have the label for those two right there for you automatically with the appropriate color style that you've set. That's the other thing is that we did not specify colors for these two plots, yet it automatically figured out, okay, I'm going to do two different colors. It's called the color cycling mechanism. I'll go into more detail about that a little later, but I could have easily have said exactly which colors I wanted if I didn't want it to figure it out automatically. And then to build on that a little bit more, if let's say I'm plotting something, but I don't want it to show it in a legend at all, I can specify a label of underscore no legend underscore, and we recognize that as a special value to not add that into a legend or some other key that we may display. So do that example, and so here I have just some stupid bar chart here, but I don't want that line to show up. Well, it didn't show up. I only have the foo bar for the bars. But if I hadn't done that, if I take that out, I'm sorry. If I had, that's right. It's a new feature in Piplot that if you don't have any label at all, we don't automatically assign one. We used to do that. We stopped doing that. So based on your version of Matplotlib, it's better, sometimes just better to be explicit and say no label, but we stopped doing automatic like plot 1, plot 2, or line 1. We used to do that, and people didn't like it. So, but if I say Baz, I can have that in my legend if I wanted it to be there. Or if you have old versions, it will come up. It will just simply be the line, and like it won't say anything, or it will say some default value, and people didn't like that. So you can always say no legend.
I want to ask you a question about a legend. Like, let's say, sometimes they don't want to put the legend high. They want to move the legend to the right side so they can see the data. I wonder how, let's say, how can I move it to the right side so I can view the data analysis?
So the question is, by default, it's going to go into this upper right-hand corner. But you want it, now, there's two things. You can put it in other places in the graph, but there's also, you can put it outside of the axes as well. I'm not going to cover that, as a little bit more advanced, but I will show you this. You can say LOC for loc best. and it will try to figure out a location based upon the data that it has that is mostly clear. It's not perfect, but it's pretty good. And then if you go into the documentation for the legend, there's other locations that you can specify. See if I remember those values. I think you could do center, things like that. So you can control the placement of your legend everywhere. And there's a lot of stuff you can do with your legend. It's all in the documentation to do a lot more advanced placements and styling. Yes, anything else? Okay. Next section, ticks, tick lines, tick labels, and tickers. This is a common source of confusion. These are 4 different things, but people don't recognize that they're different. They're all related, but they are different. A tick is the location of a tick label. So that you have a tick label for the value of 5. A tick line is the line that actually denotes the tick. The tick label is the label for the tick at that location. The ticker is an object that we have to automatically determine what ticks to have. I know, that's a little bit confusing. So what you have noticed is that in all these plots I have done so far, I never had to specify what values to show on the axes. So here it automatically determined that it automatically chose values of 0, 5, 10, 15, 20, 25. But meanwhile, here on this x-axis here, I have 1.0, 1.5, 2.0, 2.5. How does it figure that out? Magic. It's the ticker. Based upon the data that you have given the axes so far, it tries to figure out a set of tick values so that we have approximately 5 ticks, 5 or 6 ticks. We have a rule-based thing that tries to figure out exactly what ticks to have based upon the range of values that are given. That's the default. We can override that with other tickers, where in which you can provide rules of I need it to always be at 10s, or I need it to always be on 2s, or some other crazy rule. You can totally take control of that anytime you want. But the default is the auto ticker and other tickers that will specify what ticks to display in your plot. So the tick is the location. Tick line is the actual visual line that you see. A tick label is the label that shows up below that tick line, and the ticker determines what ticks to have. And then there's the function tick params under the Piplot module, or under the under the axis object. Is a method under axis object that will help you configure your tickers and your ticks and how they look. So we're going to do an example here where I will create a very simple plot. I can explicitly say what ticks I want. So the values at which I'm displaying my ticks is going to be range 1, 2, 3, 4. You guys learned about the range function yesterday, right? And then for the x-axis, I'm going to set the labels, 4 labels, to be 3, 100, -12, and the string foo, because they're just labels. And then I have some tick parameters. I'm going to say that I want the ticks on the y-axis to be in and out. So it's going to go through you're gonna see the tick on both ways, and I'm gonna say how long they are. So I've done 3 things here. I've set the tick locations and the tick labels on the x-axis, and I've set some parameters for the y-axis. And so we see, it might be a little too small here, so I'm going to zoom in a little bit here. You'll see that on my y-axis, these tick lines are going through the spine, and that I have 3, 100, -12, and food. Because they're just labels. I can call them whatever I want. But by default, this Matplotlib will assume that the labels are going to be the values, the tick values. It's magic. Yeah.
Why are the ticks numbers 1, 2, 3, 4 rather than 0, 1, 2, 3?
Right, because I explicitly stated that I want those labels to be 3, 100, -12, and food. I explicitly stated it.
The line before that.
I'm sorry, but the one before, so you're talking about for these?
Right.
You talk about for this bar graph here.
Right, so those are locations in relation to the data?
Well, because the data, when I did the bar plot, the x-axis had values 1, 2, 3, 4. And so the bar plot, because the bar, the default behavior is that the edge of the bar is going to be at the location you specify rather than the middle of it. It's a stupid little thing. You can control that. You can say that you want it to be at the middle. But so now you're saying that why is there 1.0, 1.5, 2.0, 2.5, and not 1, 2, 3, 4?
No, I did the set tick command, but I think that
You talk about here.
no, the next block, the set tick command.
Yeah, this one. Because I overrode, because I said explicitly that I want the tick labels to be these values, and that the ticks are going to be, so it doesn't matter the data that I gave it here. I overrode all that with these 2 lines. So basically, I effectively overrode the auto-scaling thing. I overrode the ticking. I overrode all of that because I explicitly stated that I want the ticks to be these 4 ticks, 1, 2, 3, 4, at the data location, 1, 2, 3, 4, but that those ticks are going to have these 4 labels that are completely different and unrelated to the values at that location because I can override anything. Does that help answer the question, or?
Yeah, so their locations not numbers.
Correct. They don't have to be numbers.
They're not
Right. They don't have to be. By default, they will be. But you can override anything. Yes?
I have a question on the 2 parameters. So you say x, y, the direction in now and in 10. So you say that I'm going to stop from 10 and then it's going to go up to now.
Oh, the length equal 10 refers to the length of the tick line itself. So I can make that, let's say, 50. And we'll see that the tick line is now ridiculously big. That's what the length refers to, the length of that tick line. And then I can say that I want the direction to be in. Now it went in, rather, or if I want it to be out. Yeah. Actually, ooh, that's a bug. That's a bug in the code. I got to report a bug. I know why this is happening. But now you have the tick going outward. You can control any of this. So. Was there another question? I thought there was. Yeah?
Can we only put the inside in out tick on the tick level side, not the other side? I see the boss is
Yeah, that's a bug. I got to fix that.
in and out one.
Oh, the in and out one?
Yeah,
Why?
I see the boss side.
Right. We put.
Can you only see on the tick level side, then disable the other side?
You can control whether or not ticks show up over here or not. By default, we always put ticks everywhere. There's always ticks everywhere on all four sides. But you can control which ones, which edges actually have them show or not. We'll get into that a little bit later. There'll be an exercise a little later that will do that. Was there another question?
Yes. How you put the axis is to the right and at the top and y to the right. Tick level.
Why this?
Yeah. It's asking how you put the labels on the right. No.
Yeah.
Actually, have both, but have both right and
Either
left.
way. And
You wouldn't have labels all the way around those.
Right. So you can control all of that. Just by default, it will not put labels over there. But as you'll see, we'll do an example where which you can add labels to other locations. Like I said, you have full control. A lot of questions that you guys will ask me, can you do this? Can you do that? The answer is yes. I'll just say ahead of time for you. Yes, the answer is yes, you can. Just how much pain do you want to go through? It's the same answer I tell my coworkers at work. You know, can we do this and that in Python? I go, yeah, you can. Yeah, if you want your arrays to be indexed at index 1, yes, we could make that happen. Just, do you really want to? Yeah. Yeah. But there are other things that, yeah, it's perfectly fine to do things like that, and I'll show some examples of how we do that. All right, so talk a little bit more about subplots. We were talking a little bit earlier about how we were add subplot or calling the subplots function. We'll talk a little bit about that some more. So here I do an example where I have 121. So it's one row, two columns. And I'm going to do the first axis. I do some plotting. And then I'm going to do a second axis, 1, 2, 2. So it's the second one. I do some more plotting there. And I'm going to add a subtitle to the fig. There I go. I have two axes that are completely different, have completely different limits and things like that. And so this was one way how I can create subplots. The other ways I can do it is the subplots function, note the plural, which I demoed a little bit earlier. There is subplot and fig.addSubplot. They're identical. That's what I'm doing up here. Then there's plot.axes, where if you actually want to specify exactly the axes you want, it's not really a subplot type of thing. It's you are manually placing the axes object wherever you want it to be in the figure. Then there's subplot to grid, which is a very nifty function. You can do more complicated grid layouts. So you can say that I want this particular axis to span, a couple columns. Meanwhile, this one, is going to be one row and stuff like that. Then there's also the subplot tool. There's an interactive tool. After you do plot, you can trigger the subplot tool to come up in interactive mode, and you can adjust margins and things like that, which leads us into the next section. The spacing between the subplots. So I just showed this example here where I have these two subplots, and everything looks hunky-dory, everything's nice, and you would put that in a paper. Sure. I'm going to show you. Meanwhile, however, the spacing between these plots are determined automatically based upon default values that are in Matplotlib package. However, you may not like the fact that there's this much space, or you may not like the spacing between the subtitle and the axes, or you might not like a variety of things. You can control all of that through a command called subplots adjust, and you can specify different parameters of the amount of spacing between different parts. The values here are in fractions of the axes. So I'll show you. It's easier to show than explain. So here I have W space, which is the width. The width space. Then there's H space, which is the height spacing. There's left margin, right margin, and then there's the top margin and the bottom margin. So let's make bottom right here is, so I have 4 subplots here, and so I'm going to change the bottom margin to be from 0.1 to 0.3. Let me, should we see that? Let me make it a little bit more extreme. So we now have very tight spacing here with the plot. Let's take a look at W space. Let's increase that. You made them further apart. Let's increase this. You can increase and decrease different values, and you can set all sorts of interesting combinations of things and get your different spacing. So it used to be, back in the olden days, this is what you had to do to make your plot look very, very nice. You don't have to do this anymore, but you can. You have full control over this. I'm going to show you, though, what can happen when you have too many axes. This god-awful, ugly thing. Matplotlib has no automatic layout system. It does exactly what you tell it to do. You wanted 4 axes, and through the default system, these axes are going to be laid out in such a way with such an amount of spacing. It doesn't go, oh, we got text here, and I need to shove this around and move that around and things like that. It doesn't do that by default. It doesn't have any sort of layout engine and re-rendering and things like that. However, and it still doesn't really have that. However, we have a nifty trick called tight layout. And so I'm going to turn that on. I'm going to replot this. It will automatically, based upon the spacing and everything of all your labels that you have in your figure, it will go, oh, I need to shrink the axes this way so much. I need to shrink and space things out that way so that no text will overlap any of the axes, any of the other axes. Always do this command last before saving your figure or showing your figure. If you do other things afterwards, it may not quite do what you want. So this is a nifty thing to make sure that your plots are laying out very nicely. Grid spec, again, continuing on with the whole thing, concept of the subplots. Grid spec is the mechanism by which we lay out these subplots in such a way, and if you really want full control over that, you can access the grid spec directly if you want. I'm not going to go too much into that, but that's what it's called, grid spec. Sharing axes. All right, so this example, I'm going to go out of the inline mode. If some of you guys were having trouble with non-inline mode yesterday in IPython, you're going to have trouble here in a moment. So maybe it might be good not to execute this following code block, but let me show it. So I'm going to show how to share two axes. This is a common need, is that I am showing two plots. They're going to be two separate axes, but I want to make sure that they both have the same limits for the x-axis or the y-axis. I want to make sure that they're always the same for the auto-scaling or any other manipulations. So I'm going to plot two things that have completely different ranges. I'm going to say that the share x and the share y are true. You can do one or both. It doesn't matter. Well, it matters based on what you want to do. It should have gone out of... Yeah. Okay, it should have gone out of that mode, but it didn't. Wonderful. One thing that I would have been able to show in this mode is that as I zoom in and out on one of these plots, or as I pan around, the other one will move as well because I set them to share. And so it's a really, really nifty feature when doing interactive plotting is to have these graphs sync up with each other in such a way that I only have to move things around in one spot in one of the plots, and it will automatically do it in the other ones for you. So, all right, go back into inline mode. Okay. Related to sharing axes, you can twin an axis as well. They're not exactly the same thing, but the idea is that you may have often seen that you have a plot, you're plotting one set of data, but you're also plotting another set of data with a completely different range, but you want it on top of your plot. This is twinning. So here I'm going to create a subplot 1, 1. So I just have x1. I'm going to plot a set of values, the range 1 to 4. And then I'm going to create a twin x. I'm going to twin the x-axis. So I'm going to create a new axis object, but it's going to share the x-axis. So I'm going to basically have two completely different y-axes. And so I'm going to scatter. Again, the x range is still going to be 1, 2, 3, 4, but the y range is going to be, in the 10s, not in the 1s. So it's going to be completely different. I can set my x label on the first axis and set my y label on the first axis. But then on the second axis, I'm going to set another label, and you'll get this. I have y-axis for the second axes. I have a y-axis for the first axis object, all on top of each other. And again, if I have an interactive mode stuff going on, if I pan and zoom, everything will move in line with each other. So very nifty option there. And so the idea is that they have the same x-axis, but two different y-axes, and we automatically put the second one on the other side for you. And you can twin the y-axis as well. So you can say that you want these two axes object to have the same y-axis, but then two different x-axes. So you can put something on the bottom and something on the top. A scale on the top, a scale on the bottom, but then they have the same y-axis. And again, everything shares and works as you want it to do. Any questions on twinning? Okay. This is a common request that comes up. How do I do this? It's called twinning.
Is the left axis will always be the one you do first? Is that true? The labels?
I'm sorry, say that
The
again?
left side is...
The left side will be the first one. The right side will be the twinned ones. And then for when you're twinning y, the bottom one will be for the first axis, the top one will be for the twin. I don't think you can actually modify that. Well, you probably technically could, but it's just easier to just be binary and just flip if you want it the other way around. So, axis spines. Sorry, is there another question? Sorry, say it again?
Trying to figure out how you
How to
how do you put a legend on?
just say ax.legend. Or, actually, yes, very good point. So if you were to do a legend and you want that legend to show the content of both of them, you have two separate axes objects. You're absolutely right. So in this case, so let's say I love IPython Notebook for this. I can quickly edit this and I can show you guys this on the fly. So label equals Austin. Label equals Philadelphia. And, I showed you guys earlier that you do, ax.legend, but now I have two legends. So what do? I'm only going to get one of the labels, right? And so that's the problem that you're asking here. How do I get both of them in the same legend, right? So what you do is fig.legend, or is it takes 3 arguments, right? Yeah, so you have to so I would have you have to save, if I remember correctly, you have to save those artists and then you have to pass them into the legend. So P1, P2. Is that right? So now I'm trying to remember. It's definitely Fig Legend. I'm just completely and utterly blanking on that. But the idea is that the figure is going to be the one responsible for handling it because it knows the two axes object. I'd have to look it up, but that's essentially it.
So I have a question on that one.
Mm-hmm.
So if I want to make like the scatter plot are red, the actual dots red, and the axis label and the tick marks red, so that it draws the attention one way or the other. I've got the colors on both the data, so the dots red, and I can get the label red, but I can't figure out how to do the tick marks red.
The tick params that I showed you earlier, that's how you would do it. You would do it through that.
And I've tried that, it's not working.
Uh,
So I set tick labels?
where did I do? The tick params. Tick params, you can set color for the tick.
Tick params.
Yeah. So that's how you do it. Through tick params, you would set the color that way. Any other questions?
If I point out this legend question, you don't have to, well, at least I never looked up first, I just put IPython, tell me, give me the doc string for that function.
Yeah.
Just nicely inline.
Oh, right, yeah. I can do... Oh, okay. Right, that's what it wants. Because it wants you to actually give it the label. So P1, P2, that seems stupid. We need to fix that. Because those two objects already have labels. I don't need to tell it what the label will be. So foo.
Then you can just do that on the axis.
I can?
Yeah, you don't need the labels.
Right. Oh no, if I did ax1.legend, it doesn't know the other one.
No, that's the two lines.
Hmm?
That's the two lines, but it always has to pick up the label.
No, I tried doing that and it said that it needed it needed some more arguments.
Can you do it on the axis?
Right. You are absolutely right. Let me make the changes. Whoa, yeah. I think we have a bug, Phil.
You're passing a list of lines, not a line of it.
A list of lines rather than.
Yeah. The P1 is a list of lines.
Right. And then scatter, the same thing, right? Oh, no, it's a path collection, so. Yeah. Yeah, funny story I have about that. I used to think that scatter and plot were basically interchangeable. And one time I had a bunch of, code that was doing scatter plots, or a bunch of code that was doing plots, but I needed to change it to scatter. So I just did a find and replace of plot to scatter, and then it failed on that it couldn't import matplotlib. I'll be here all week, so just don't forget to tip your waitress. Okay, so here we have line 2D. Yeah, Phil, we got a problem. We need to make sure we fix that. Something's not right here. All right, moving on. So it's definitely more complicated than it needs to be. We can make that a lot better. So the thing here that frames these axes are called spines. And we can control that. So the default is that we have this framed box. But you can do anything you darn well please. And I'm going to show you a few ways that you can play around with it. So the first is going to be the outward setting. So the idea is that you set the spines out away from the axes. And so I have this configuration. It looks completely different, but many people like this style. You can explicitly say to do that. Now let's try something different. Let's try a different setup where we'll have things, the spine set up according to where certain values at the data coordinates. So here I'm going to say that I want the bottom spine and the left spine to be placed at 0, 0. So I want them to meet at 0, 0 in the data. Look at that. There's some people who are going to want that, right? That's a useful, nifty thing. Note that I made the other two spines disappear. I set visible false. And then I also said that I want that the ticks be placed only at the bottom and only on the left. So if I hadn't done these two set tick positions, I'm going to see little ticks around the edges over here too, and I don't want that. So I'm going to say that I only want them attached to these two spines. So another thing that you could do is to have things set according to the specific location. Oh, so with that data one, if I were to be panning and zooming around, the spines would move too. So that way they're always intersecting at 0, 0. But I can also say that I want the spine to be at a specific location relative to the axis itself. So here I have an example where I want it to be 3/4 of the way in and 1/4 of the way in for the bottom and the left. And what will happen is it'll get placed on that. If I pan and zoom around, those spines are not going to move, but the limits will change. as I pan and zoom, but they will stay exactly right there. And there are a couple other modes, and we'll get into that with the next exercise. So, take a few minutes. I want you guys to create a plot that have outward spines on the left and the bottom with tick labels, and centered spines with no tick labels and tick marks through the spine. And so I want you guys will probably, as a hint, tick params and set position. And you can get started with loading up the exercise example. You'll modify this example to do that particular job. So we'll take about 5 minutes and we'll do that. We're almost to the end of the first section. So probably in about 10 minutes or so, we'll take our first break. In case some of you guys are wondering, like, when are we going to do more stuff? The next part is going to have a lot more exercises, so. Anybody utterly stuck and can't figure it out? Anybody figured it out? Still churning, huh? How about we make it a race? First one to figure it out, raise your hand. You get extra credit. I have nothing to actually give you, but you'll get a gold star or something, I don't know. I can almost see the steam coming off your heads. Just Anybody need more time to figure it out? It is doable. It is quite doable. We'll move on to the solution now. So, do the plotting. So for the ax.spine top, I'm going to set the position to be center. For ax.spine right, I'm going to set the position to be center. That means I have 2 more spines left to play around with, because you get 4 of them. Well, but also for the tick params, for both of them, I'm going to say that I want the direction of the tick to be in and out at a length of, let's say, 10. It could be any length, whatever. Now, for the 2 remaining spines, the bottom and the left, I'm going to set their position to be outward and to be 10, I think they're points away from the axes. And it will look like this. Oh, put it down. To execute there we go. There we go. We have ourselves 2 centered spines right here. They're always going to stay right there in the middle of the axes. And then I got 2 other spines here on the outward away from it that will actually have the tick labels. So that way the tick labels don't show up on these 2 spines. Quite simple.
Can you show the solution again?
And the solution will be posted on GitHub after the end of this tutorial. But yeah, so just simply set the positions of the top and the right one to center. And then modify the tick parameters to be in and out. And then I'm going to say that the bottom and the left ones are going to be outward. So I'm just combining. So by the way, the center is analogous to saying that the saying axes 0.5 as a position. It's just simply a shorthand because you're saying you want it to be in the center of the plot. So, but I could have easily said axes, comma 0.5 as being a position for right and left. So it's just simply a modification of this existing script with the appropriate values. So. Anybody confused with that solution? All right. Getting towards the end here. It's the very last thing, color bars. So we talked about legends as a way to label your data. Well, color bars are basically another way of labeling your data. It labels your anything that can be scaled. And it's called technically speaking, in Matplotlib, it's called a scalar mappable. So something that, given a value, you can map it to between 0 and 1, and we can assign it a property, most likely color. So, and usually these are images type things. So here I'm going to show a simple image with a color bar. And just like that. And so it shows up on the side there. And you can modify how that color bar appears. So here I'm going to make it smaller and horizontal. Just like that. Nice and easy. And just like just like many other plots and stuff, we can add legends. We can add a label to it. So there it has a label, and I even did a little extra thing to show what, have a little triangle at the top and bottom of the color bar to indicate that this is, had values above and below as well. I will admit that the color bars can be a little bit difficult to play around with in Matplotlib, and the documentation is a little obtuse. We're working on that, but one of the most common issues is what I'm going to show you right now, where you have 2 subplots and then you want one color bar and that color bar refers to the two subplots. This happens. I can't tell you how often I get this question. And there's a reason. So as part of Matplotlib being helpful, when you call color bar, you didn't tell it where you want the color bar. You didn't tell what size is and things like that. And Matplotlib, its various subplots are already taking up the full figure. There's no extra space left. So what you do is when you call color bar, it steals that space from the last axes object from the axes object that it's going to be right next to. So it stole a little bit of it, and so that axes object had to be shrunk a little bit because it had to give some of its space to the color bar. This is obviously undesirable. So it is really, 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 really simple to fix, though. You can pass it, depending on which version of Matplotlib. I think we introduced this feature in 1.2, if I remember correctly. 1.1 does not have this feature. You can pass to color bar the list of axes objects that you want it to steal from. So it will steal equally from each of these axes objects that you're going to want to modify. And that way they both shrink the same amount. So however much space it needs, it will steal it proportionally from each one. That way they all end up looking similar. So nifty little feature there. There's also another feature called Axes Grid 1. Don't ask why we have it Axes Grid 1 and not just Axes Grid. It's a long story. Where you can actually, as part of specifying all your subplots, you can say, also please allocate some space for me for so many color bars, either a color bar for each one of these or a color bar just on the side or just on the bottom. You can say that I want you to allocate that space ahead of time for me, and you actually be given that space separately that you can play around with, and you can create your color bars in there. That's a more advanced thing. I'll show that in a later section. So now we have reached the end of this. Any questions on color bars? Yes.
Would it be how like a 5 or 6 figure when I have a what for the last one? Would it be how like 4, 5, or 6 more than 2 color e-color figure and try to share the color?
So the question is, what if you had more axes than that? The list of axes that you pass in are the ones that you want it to steal from. It will figure out how much to steal from each one. So if I passed in only 2, but I had 6 of them total, it's only going to steal space from those 2. So it's going to shrink those 2. The other ones are going to be left unchanged. So if you didn't tell it all the ones you wanted to steal from, it's not going to quite do what you want. So. But it did exactly what you told it to do. It's to steal space from whatever ones you told it to. Any other questions? Yeah. Okay. Welcome to the very reason why Matplotlib was created by John Hunter. That was the very reason why, because he was doing those brain scans, and he needed to see them in multiple color maps. And Matplotlib, you can only set one color map for a figure. It used to be there was one color map globally. Even if you had multiple figures, but they eventually managed to make it so that, it was one color map per figure. And welcome to one of the reasons why I discovered Matplotlib was I'm a meteorologist, and I was doing radar imagery, and I needed to see Doppler and reflectivities, and it made me have to have them in separate figures when I want them in the same spot, but they're completely different color maps. Can't do that. So that's one of the reasons I got pushed over to Matplotlib. So Matplotlib, by default, has a default color map. And I'm going to talk about this in the next section about color maps. But you have full control. You can say specifically that I want this scalar mappable to use this color map. I want that scalar mappable to use that color map. So you have full control over that. John Hunter made absolutely certain you can do that. You're welcome. There's another question?
Related, I guess, but just introducing something with the idea of adding an access
Having an axis, then you assign a color map to the axis. You don't assign a color map to the axis. You assign a color map to the scalar mappable. So the image that I created will have a color map attached to it, not the axis. That sort of what you're getting at? Or
even needing multiple color maps associated with the same, you could get land data, including certain things in particular.
so the question is, like, how do you deal with, can you have multiple color maps with multiple data? Each scalar mappable. So this IM show that I did here, while I didn't save it anywhere, it produces a scalar mappable. That is a scalar mappable. It gets a color map. So by default, it's given the same color map, but I can override that color map at any time that I want. So let's say, plot out some land data. I do an IM show on some land data, and I give it a color map. I then can plot out, let's say, some surface feature, let's say city stuff or something like that, and I overlay that on top of that image. I can give that another color map. They're completely separate, but one color map per scalar mappable. You can't have two color maps because that just doesn't make any sense. You plot it only one way, but you can change that color map at any time. All right, let's take our first break, walk around. Wow, that was a 2-hour segment.